Hello, welcome to a winter-themed coding challenge. Something that I should say is this coding challenge is probably very similar to my previous Purple Rain coding challenge. But instead of purple rain, we're going to have wintry white snow. So I've got a blank P5.js sketch here. I am going to try to make little snow particles that fall. I'm getting some suggestions from the chat about like wind and that type of thing. So let's just get started. Ooh, I got a nice PNG snowflake there. Okay, so I'm getting lots of, I don't know how this is gonna go. You might be watching this as a recorded video sometime in the future from your spaceship that's flying around. But at the time of this recording, there's a live chat going on, and I'm going to try to get some good suggestions. So the very first thing that I need to do, this is my code, that's all it is. I'm going to start with an object-oriented approach. And I'm actually going to make a new JavaScript file, and I'm going to call that file snowflake.js. And I am going to make a class called Snowflake. And that class is going to have a constructor, and it's going to have a position. And all of these are going to be vector objects. If you haven't seen a vector object yet, a vector is an object that holds an x and a y and a z, because we could do this later, maybe as part 2 in 3D and WebGL, and we could swirl around the snow and go through it in 3D. Oh boy, wouldn't that be exciting? But we need a velocity. And we need an acceleration. All right, now, also we want a function just to render the snowflake. And for now, I'm just going to say it's white, and it's about 4 pixels wide, and it is just a point. And so the point will be at the position, the x and y position. Ooh, look at this. I'm getting a wonderful sprite sheet of snow textures. We're going to grab that. So thank you. I'm seeing that being submitted. Alka, if you could make me a nice URL that I can download it here as we're going. All right. So what do I want to do now? OK, so I definitely want to have an array. So I'm going to make an array, empty array. I'm going to call it snow. And what I'm going to do is I'm going to say snow.push a new snowflake. So I'm going to have at least one new snowflake. I'm going to have one new snowflake. And then I'm going to say for every flake of snow, right? This is my new favorite kind of JavaScript loop where I have an array of many things, and I can say for every element in that array, but it's of. In does something different. Oh, I got to do a video about that because I really botched my previous one. I'm going to say flake.render. And let's probably pass in, never mind. Let's set the location of the snow in the constructor itself. Let's just hard code it right now. And let's see what we get. Oh, snowflake is not defined. Why is Snowflake not defined? Because I forgot in my HTML file to reference that JavaScript file. And I'm being told by Simon that maybe I have a syntax error somewhere. I'm not sure where. Let's just see what happens. Ah, there it is. There is a beautiful snowflake. I have a keyboard now. I don't know how to use it yet, but very excited about this addition. OK, there is the beautiful snowflake. Now, what I could do is I could actually say in draw, let's keep adding snowflakes. Now, I think I'm adding many, many, many snowflakes, but they're all being added right in the same spot. So let's add all of our snowflakes at a random location. Let's pick a random width, a random x position, and a random y position. Snow! Yay! It's snowing! Let's go sledding! I don't know. Why is this associated with snow in my head or the winter or something? Anyway, now, here's the thing. I think I want to create all my snowflakes above, off the screen, and have them fall down. So let's do that. So let's actually, in the Snowflake object, let's create the y location something like between -100 and -10. So somewhere above the window. So now if I were to rerun this sketch, I won't see any of it. But I can add a function. I'm going to call it update. And what I'm going to do in update is I'm going to add the velocity to the position. And breaking news, breaking news, somebody will make me that sound effect eventually. I now have our sprite sheet. There we go. So let me download this. Desktop, snow, and I'll call it Flakes 16. Okay, so we've got some images we'll be able to use later. Great. Okay, now what I was saying is the position of each snowflake needs to change over time. How about based on the object's velocity? So I can use vector math to say add the velocity to the position every frame. And so I can now say flake.update. I want them all to update. Now, I still don't see them moving down because none of them have a velocity. So I could do something just to test. And I could say, hey, give all of them a velocity vector that's kind of fast pointing down, like 0, 5. And we would see there's all the snow. But this is not really snow yet, right? What we want, I mean, it's never going to be actual snow. Wouldn't that be wonderful if I could sort of magically, I need more props, have snow falling in. But what I want is I want to see it feel a little bit more like gravity. So what I'm going to do is I'm actually going to create a global variable called gravity. Because gravity isn't part of a snowflake, it's part of the world, so to speak. And I'm going to say gravity equals create vector, and I'm going to make up something, a small gravity pointing down. And then actually what I want to do is, again, I want the velocity to start at 0, but I want the acceleration equal to gravity, and I want to add the object's acceleration to its velocity. So I'm going to do more with this in a little bit, but the idea is gravity is a force. A force is a vector that moves an object with mass, that accelerates an object with mass. F equals m times a, right? So what I want to do is take the gravity force and put it in the object's acceleration, which changes the velocity over time. And what we would see now is snow starting to fall faster as it gets further down. Great, so this is starting to look a little bit more like snow. There's a lot more for us to do here. We want to add some wind. You know, we probably want the gravity in the case of snow. Gravity is probably the wrong word. I should just to be very light. So it feels like it's moving very, very slowly. However, I wanted to create this parallax effect. So, so how do I do that? Let's think about this. Well, one thing I would like to do is give the snowflakes themselves some kind of size. So let's try this. Let's give them a property called R. That's a random number between 4 and 8, and use that as the stroke weight. And we can see now this is kind of nice, right? So this is nice. Now, somebody in the chat, I want some help here. So what do I want? I want the bigger ones falling slower and the smaller ones falling faster. No, the other way around. If something's further away, it's smaller, and it will look like it's falling slower. If it's bigger, it's closer. It'll look like it's falling faster. Is that right? And so should I actually just alter the gravity? Like, let's make a copy of the gravity vector. So one thing I should do, okay, so first of all, I should write a function called apply force. And that takes a force, and what it does is it just adds that force to the object's acceleration. And then I clear out the acceleration every frame. So this is known as force accumulation. I have lots of videos that go through this in more detail, but the idea, there's different techniques for doing this, that what I want to do is say there's a bunch of forces in the world. I want to accumulate all of those forces. So, like I might have some wind, I might have some gravity. So, and we maybe will add some like Perlin-Noyes flow field kind of thing. Yes, I need to have a mass, and all that. People are giving me great suggestions in the chat. I'm going to get to those. Not ready yet. So what I really want to do is I just want to say flake.apply force gravity. Because the gravity is a force that's coming from outside that I want to send into each snowflake. So this should really be the same exact sketch. Now we've really got to fix something before we get too far. So number one is I either want to like recycle the snowflakes when they get to the bottom or remove them. Because as you know, this is already running really slow after a little while. Let's deal with that. So what I want to do is I want to loop and actually, I'm going to do this thing that I do in lots of coding challenges, where I'm going to loop through an array backwards. And I'm going to say if flake off screen snow.splice I can't type today. I, comma 1. So what am I doing? So what I'm doing here is I want to go through every, this is flake. If snow index I is off screen. So I need to use an iterator, a counter, to go through all the elements of the array because I want to eventually use the splice function, which removes something from the array. And the thing that it removes, I specify the index. So I want to remove the snowflake at that index, and just the one. I don't want to remove the one after. And I'm going through the array backwards. So as I remove them, the array slides down and is shorter, and I don't end up missing any elements. I've definitely done this in other videos before. OK, so this isn't going to work because this idea of something off screen isn't magic. So I need to go back to the snowflake object, and I need to write a function called off screen. And yeah, I'm being told, breaking news, I'm being told that I have I++ somewhere where I need I minus minus. I will fix that. It definitely would result in a problematic infinite loop. I now want to say return of the Boolean value of if it's off screen. And I can determine that by saying this.pos.y is greater than, is it greater than height plus this.r. So in other words, if it's off the screen based on its size, then return. This will evaluate to true or false. If it's true, it's off the screen. All right, all right. Back to sketch now. This definitely needs to be I minus minus. Thank you for that correction. And now let's rerun this sketch. All right. Now, the question is, let's look at the length of the array. 194, 193. So that's definitely working. It's kind of hovering around 200 particles, which is reasonable to render. That's good. OK, so now I think what I want is, let's try to get that parallax effect. Let's see if we can make that happen. So what would happen if I, before I send in the force, so interestingly enough, I'm ignoring an aspect of Newton's law. So typically, I might do something like this. Right? What did I just do here? What I said is, before I take that incoming force and add it to the acceleration, divide it by mass. And that's because force equals mass times acceleration, or acceleration equals force divided by mass. So this is me dividing it by mass. Now, of course, with gravity, the force of gravity is scaled by mass because force of gravity equals the mass of one object times the mass of another object divided by distance squared. So this is kind of actually irrelevant here. This is problematic. So I'm going to not include this right now. But what I'm actually going to do is I am going to, like have a little like parallax, is that how you spell it? Parallax effect hack. Let's see if this works. Somebody will hopefully help me with this. I really need help with this. So what I want to do is I want to make a copy of that incoming force. Then I just want to, I'm just going to multiply it by the object's size. Because if it's bigger, I want that force to appear that it's stronger. And then I'm going to do that. So let's see what this does. I think it's not strong enough. And also, there's kind of an issue where, let's make this size differential much more extreme. It's sort of like, kind of, I forgot to set the terminal velocity. That's a good point. So I should have the snow have a terminal velocity. And that terminal velocity, so let's try that. Let's see if we can make this this dot terminal v equals this dot r. We're going to make it related to its size. I don't need another variable. Let's try that. Okay, so let's see. I'm very thrown off by the, so I want to say this dot velocity dot limit this dot r. So the limit is a vector function that takes a given vector and limits the length of it. So let's see how what this does. Too much speed. Yes, way too much speed, right? So let's say it's limited by its size times 20% of its size. That's better, right? All right, let's see if we can use a sprite sheet. Now, really, as an exercise to yourself, if you're watching this and you're following along, you should stop right now. More small ones and fewer big ones. Okay, great suggestion. So how do we do that? Oh, I love this suggestion. How do we pick a random number that's more likely to be small than big? Let's write a function called getRandomSize. And I'm going to just put that separately up here. Function getRandomSize. And what I'm going to do now is let's do the pick two random numbers approach. This will kind of be easy. So I want to pick two random numbers. And I'm going to say if random2 is less than random1, or it's greater than, is greater than random1. So smaller numbers will be more often, then return random1. While true. So this isn't very efficient. I feel like there's so many other more efficient techniques. But basically what I'm doing is I am trying to pick two random numbers, one which qualifies the other one. So in other words, let's say I pick 0.1. Well, now I need to pick a second random number. 0.1 is going to make it past this level 90% of the time. 0.2 is going to make it past 80% of the time. 0.8 is only going to make it past 20% of the time. So this is linear, but I think it'll do pretty well for now. And then I want to map that value, which has a value between 0 and 1, and so I don't really need to map it. I'm just going to say random1 times 36. So now we should have more smaller ones. And you can kind of see this is true, right? There's a lot more smaller ones than big ones. Okay, Lucas in the chat is giving me an excellent suggestion, which is to use the absolute value of a Gaussian distribution. Let's try that. So what I'm going to do is I'm going to comment this solution out. And I'm going to give myself a random Gaussian number. So in P5, there is a function that will give you a Gaussian distribution, which is a normalized distribution, or the bell curve. And I can alter the mean or the standard deviation. So I could say the mean, I want the mean to be 0. But I want the standard deviation to be, let's call it 36. So I'm going to say R equals random Gaussian times 36. I'm going to scale it up, and then I'm going to return the absolute value. Because random Gaussian will give me negative numbers, all centered around 0, and will give me a lot more smaller ones than larger ones. Let's take a look at this. Whoa, that's a lot more. So I don't want that standard deviation that big. I suppose I could also square it. No, I don't want the, and then, yeah, this is kind of, now I'm kind of getting somewhere, but I am kind of liking how this looks. It is running very slow over time. So why is it running so slow over time? Because I have many, many snowflakes. And in fact, I'm adding so many, but these small ones never really get to the bottom. So one thing I need to do is I need to, in addition to having a maximum velocity, I also want to say if this dot velocity magnitude is greater than, is less than 1, this dot velocity normalize. Okay, so, and is it, I don't think it's possible because there's some, and I also think that I want to say, so actually, do you know what I can do? I don't actually need to do this limiting here. I think I don't want to ever create a snowflake that's less than like 2 pixels. So another thing that I could do is I can constrain that absolute value squared between 2 pixels and 36 pixels. So now, because you can see there were just so many small ones, and so this now, if we look at the size, you know, I'm staying, it's getting bigger over time, but I'm hopefully staying a bit more within the realm of reason. Yeah, look how many small. So I think though that I do need the minimum velocity to be more than, do think that I want them to move at least. Let's try something. This dot velocity dot normalize. Okay. So this should be better, but I can also really fix the number by, as everybody is suggesting, by just recycling them. So let's try that. Let's try, instead of deleting them, let's just create a function in the Snowflake called randomize. And what that function is going to do is actually all of this stuff. And so when this dot pos dot y is greater than, see, merging, if I had just had the whiteboard, I would have drawn that graph and it would have made more sense. If this dot pos dot y is greater than height plus this dot r, then this dot randomize. So I'm just going to recycle these. Once I get to the bottom, I'm going to recycle them back up to the top. This way I can really control the number of snowflakes. I kind of want to just start this whole challenge over. So let's have 300. And let's see what happens. So this is going to consistently only ever have 300. What's a little bit interesting about this is that the smaller ones take so long to get to the bottom. Oh, I'm still adding them. So one thing that I need to do is stop adding them if I'm going to do this approach. And this we should see over time we're going to have very few large ones. So that distribution is actually going to be even smaller because the small ones take so long to go anyway. So they like stay on the screen. So actually I'm going to alter the distribution a little bit. Let's do one more. Let's do one more way of changing the size. I'm just going to pick a random number between 0 and 1, and I'm going to square that number, and I'm going to return 1 minus r. So this is now, if I had a whiteboard, I could diagram this. Okay. Oh, but I need to scale that up by 36. So you can see what this looks like. It's hard to tell, but there should be many fewer. Now, let me put that to the 10th power. Not 1 minus r. Why did I think it was 1 minus r? Oh yeah, there we go. This is what I meant to do. And what I actually want to do is have at least a minimum size of 0.1. There. This is pretty good. Let's have a minimum size of 0.2. Minimum size of 0.5. I'm just curious here. All right. Okay, so I think this now is working pretty well. And actually what I want to do is constrain that result to between 2 pixels and 36. I don't want anything less than 2 pixels. There we go. Okay, this is starting to look pretty good. Boy, have I spent, power 10 is a bit large. Oh, I didn't realize I did that, had that in there. Okay, but I kind of like it with that distribution. So if I'm going to constrain it, then I can do this. Okay, let's see how this looks. So anyway, we've seen so many different ways of creating more values that are smaller than larger. And I'm going to leave this one in here as the kind of simplest solution, which is just to take a random value between 0 and 1 and make that exponential. So I'm much more likely to pick a smaller one than a larger one because it is squaring a value less than 1 is making that value smaller. But I'm actually doing it to the 5th power, that sort of thing. Okay, so now what I want to do is finally go and let's try to use this sprite sheet. So Alka, I think generously, I think there's a 32 one. So this is going to be good. It's going to be, I'm going to do this flakes32.png. So if I understand what this image is correctly, it is a whole bunch of snowflake designs that are 32 by 32 pixels. Now, again, I would like to suggest that you as a viewer generate these algorithmically, but I'm just going to copy them from this image. So I've actually never done this before. This is a way of, what I would always do is just load these as all separate images, but it's obviously much better to load just a single image file and see if I can copy the pieces of it. So let's see if this works. Oh boy, this is exciting. Okay, so let's go to here. Let's add preload. I'm going to call this textures. And I'm going to say textures equals load image flakes32.png. Okay, so let's first just make sure that that image is there. Let's see that it's there. Oh, 0, 0. Let's draw it at 0, 0. Okay, so we can see that that image is there. So I'm getting all of these snowflake images, which is absolutely lovely. And what I want to do now is copy them into separate images. So I'm going to call this files. And I'm going to make another array called textures. Oh, file. I'm just going to call this file. And what I want to do is I want to say for every x all the way up to, I guess we could call this sprite sheet. Is that and it's not an array. Why did I set it as an array? I'm losing my mind. It's an image. It's an image. The textures will be an array. I want to load that one image and then chop it up. And I'm sure there's a way to do this automatically with some library or something, but I'm going to do it manually here. So I'm going to load that image, and then I'm going to want to go through the width of that image, x plus equal 32. So I'm going to assume that each one of those is 32 by 32. And then I want to go through the y. And then what I want to do is I want to get a new image. I want to say an image is spritesheet.get. Now what's the chance that this works? Spritesheet.get x comma y 32 32. This should pull out a slice. The get function in P5 should pull out a slice of that image, a little square just from that position. And then I can say textures dot push that image. All right, now here's the thing. I want to debug to see that this is really working, so I'm going to just get rid of the draw function completely. And what I also want to do is I am going to draw these images at their x and y location. So let's see if this actually works, if the get function does what I want it to do. Now, I can't tell if it worked because there's no background. Ah, it worked. So the get function, you can notice it took a little while there because it had to like chop everything up. That was kind of a slow process, but this actually worked. So now I have an array of all of those images. I can put the draw function back. What I want to do, I need to do this beforehand, and then what I want to do is give each one a design, which is a random texture. And I'm going to pass that design in, and each snowflake is going to get that design as an image. And I probably should put it in the randomize, but let's just get this to work. And I'm now going to say, instead of drawing it, let's say image mode center. And then, image mode center. Then I want to draw that image, its current image, with its size. OK, dare this work? Oh boy, what just happened? Oh, I didn't draw it at the right position. I've also got to include its position. And there we go. Look at all the snowflakes. Now I almost feel like because they're so lightweight, I kind of feel like I need more bigger ones. So I could go back to one of my ridiculous other techniques, or I could just lower this. Let's just square that random number. So I have more big ones, but that's too many big ones. And I should probably constrain it to 32, because that's the maximum size. There, look, it's our snow. There. We've made a nice, boy, what did it take me, like an hour? It's like 12:45. I was going to wrap this up around 1 o'clock. But I think that it would, I was going to try to add a little Perlin noise wind. All right, let's try them spinning. So I don't understand how this is going to make it look more like snow, but let's try it. So let's go here and add a variable called angle, which can be a random angle between 0 and 2 pi. And I'm going to, when I draw the snowflake, I want to say push, translate this dot pos.x, this dot pos.y, and then draw the image instead at 0, 0. And then have pop. And then after I translate, I want to rotate by some angle. OK, so let's just take a look at this first. Whoops. What did I miss? Angle is not defined. This dot, this dot, this dot. Surprised this hasn't happened to me yet. Okay. So, I don't know if you can tell. Are they rotated at random angles? It looks like they are. Yeah, I'm definitely going to do the noise function. Don't worry, everybody. It's coming. So let's have them rotate based on their velocity's magnitude. I don't know. And that's way too much because we're in, if I went to angle mode degrees, but I could just divide that by 100. They're all rotating in the same direction. That doesn't seem right. Let's have them, some of them go randomly to the other direction. So let's also have a direction. And then, oh, maybe I should write one of those fancy things, right? Where you, how do you do that? Where I have the little Boolean thing. If random1 is greater than 0.5, I give it a value of 1 or like -1. What's this thing called that everybody always uses and complains that I don't? Ternary operator, yeah. So I never use these because I am just an old-fashioned and probably so ternary operation. In code, ternary. Let's look at ternary operation syntax, JavaScript. I mean, it's the same in most. We can look at it like this. This is the condition, and if it's true, it's this one. If it's false, it's this one. So what I want to say is this, right? If random is greater than 0.5, give it a value of 1, otherwise -1. All right? So I think this should work because now I want to change the angle. And this should be an update, by the way. I want to change the angle by this times this dot direction times this. So some of them will go randomly to the other side. Okay, so this is nice with them spinning. Okay, so now I want to do some side-to-side motion. So some options are sine wave, Perlin noise, wind, actual like a wind force. What does everybody think? Perlin noise, wind. They spin too fast. It is kind of fast, right? So let's make them spin slower. Sine. Alka is suggesting a sine wave. So a sine wave, just to have them sway left and right, like not as a force, but as just an oscillating motion. Interesting. I have not tried this. So I then would need to have some sort of offset, which is the result of sine of maybe that angle. I don't know why I said random. I want to map. Oh, I don't actually need to map because sine goes between -1 and 1 times, maybe I could use their size. And then I can just, so they need to have an x offset, which is 0. I'm going to make this a property of the object. And then I'm going to just use that. And let's see what happens here. Whoops. What did I miss? What did I get wrong here? Angle is not defined. This dot, this dot, this dot, this dot's on. This dot angle. Okay, let's try this. Ooh. What do we think of this? So I could also have them do this with a little wind. This is pretty nice. This is turning out quite lovely. Let me get rid of the console. This is actually quite nice. All right, now, I really want to put some wind in here. Now, what can I add? I want to create some Perlin noise wind. So the first thing I just want to see is let me just create some global wind. So in draw, let me create a variable called wind, create vector. And I am going to have that be, the wind x is going to be, just going to control it from the mouse. And I'm going to create a vector with that. I'm going to create a vector, and then I'm going to also apply that force. So I create a vector. So I just want to see how this looks. So you can see this wind is much too strong, and it's also very uniform. So that's not good, but it is kind of, it's the right idea. So I just want to sort of see what the range of magnitude that makes sense is. Oh, one issue is because I'm constraining them with like a top speed, if the x force takes over, they are not falling anymore. So I really should, oh, this is so problematic. All my weird constraints in here. But let's make the wind much weaker. So with a weaker wind, okay. So this is kind of, there's some issues here because as they start to accelerate more and more, but I think as long as I keep the wind fairly weak, we're going to be fine here. But I could probably do a better job with the constraining. Now, what if I now have the wind be Perlin noise, Z? So instead, I'm going to have, and I'm going to do this in a weird sort of way, because what I want also is I kind of want to have more of a flow field kind of wind. So it's different all over, and I could also have the wind pushing it down a little bit. With the wind, and I could have the wind be a vector. Oh, an angle. Ooh, okay, this is really good. So actually, hold on. So let me change this. Let me have a x offset equal to 0. And now what I'm going to do is I am going to say let wind angle equal noise of x offset times 2 pi. Then I'm going to make a vector from that angle. And then I'm going to do that right now, and then I'm going to let x offset. And I should control it by the mouse just to see if this is working, but let's let that x offset go up in time. So you can see this is kind of like nuts because it's changing so often and it's quite strong. So some things that I need to do are, number one is shrink that wind down by quite a bit, and also have it change less often. And now you can see it's totally uniform. So I really don't want to have the same wind for each snowflake. Oh, and of course now I have to have the snowflakes wrap. So, and by wrap I don't mean wrap music-wise. I need them, if they go off the left, to come back on the other side as well, or to randomize and go back from the top. So, first of all, I want to make this wind much smaller, and I'm going to need different wind for each flake. So I am now going to have the noise, x offset is going to be the z. I want to say, this is going to be now called z offset. This is kind of like crazy what I'm doing. Without like diagramming this or really explaining it. what I'm going to attempt to do is I'm going to have an x offset, which is going to equal the flake's x position divided by the width of the window. And the y offset is going to be the snow's y position divided by height. And so I'm going to get, the wind is going to be different depending on where you are, with changing very, very slowly over time. And this should not be here anymore. This has to be here. So now what we should get is, there we go. We have a nice flow fieldy distribution of wind. So that was kind of like overly complicated. I think what I'm going to do is when they leave the screen, I've just set them back up to the top. So I think in the Snowflake, if they, where do I set them? So I can say if this.pos.x, so I kind of want this off-screen function. Because what I want to do is return this, or this.pos.x is less than negative this.r, or this.pos.x is greater than negative, that is greater than width plus this.r. So if any of these are true, it's off screen. And then here, it's much simpler for me to just say, if this.offScreen, randomize. Okay. And Alka's making a good point, or Simon's making a good point, that I could start, that I could constrain that angle so the wind really kind of. So I think, well, let's take a look at this. I think this is better now. Now, can you really see that there's wind? Let's try to make that wind much bigger. So what I want to do, and I really should put this in the Snowflake as a function. I should let them enter the opposite side. Okay, that's a really good point. Because it's weird that they're not entering from the side. So what I'll do, that's actually a really good point. Let me change that. Oh, that's so smart. So I think I'm going to go back to what it was before. Whoops. What am I doing here? There, okay. So so I could still use the randomize. You know what? I should just have them wrap around. So they only randomize when they get to the bottom. If this.pos.x is less than this.r is less than this.r, negative this.r. Only thing is I can't really guarantee that they're going to re-enter on the other side, but let's try it. Let's say this.pos.x equals this.width plus this.r. And let's just try if it is greater than width plus this.r, let's set that to negative. Let's just try this. This is wrapping left and right. Let's see if this kind of has a nicer effect. Width, not this.width. Thank you. That was a mistake. So this should help. So hopefully that helps a little bit. I kind of want to have more snow. It feels like it's too few particles. So I'm going to go back to the sketch and see if I can get away with 400. Okay, now I want to see the wind be a little bit stronger, just to have a sense that that's actually doing something. And so I'm going to do that here. I'm going to make the wind 10 times as strong, just to sort of see. Yeah. So you can see that, whoa, there's a lot more swirling going on here. So that's kind of interesting. I mean, finding the right balance there. You can see how there's a flow field that they're following. The gravity probably needs to be a lot stronger if I'm going to make that wind that much stronger. So let's go and make the gravity also stronger. So I don't know what's going to cancel what out. But you can see balancing those two forces of the wind and gravity. The sine wave, I kind of want to see the sine wave also maybe be a little bit more prominent. So where do I calculate that? That x offset, let's just expand that by 5, just out of curiosity. Yeah, so that's too much. But let's expand it by 2. And maybe that angle is kind of, because it's tied to the spinning. So I could actually also have it oscillate twice as fast. So I don't know. There's Perlin noise wind. There's oscillating sine waves. I think maybe wind should change over time. It is changing over time if I programmed it correctly. The wind is changing over time because the z offset is changing over time. I could make that happen much faster. I don't know how noticeable this will be. So now there are so many parameters here. So this, I don't know that this was a coding challenge. This was more just like, I think this live stream might just stand alone as a live stream in all of its mess. Maybe I'll edit this out. Maybe I'll come back and redo this coding challenge. But what I would like is to see people do creative variations on this. So what are some things you could do? Number one is you could be more thoughtful about the design. You could add other elements to the scene. You could have the snow pile up. You could generate algorithmic snowflake designs. You could be more, you could create a lot of sliders to control all the different possibilities here. But this, I could do a background. I should do a background. I could add some text, make some of them translucent. Oh my God, so many different possibilities. So I'm going to leave that. Maybe I'll come back and add some of those features, but we're going to save this. And I am now going to go back. I'm now going to go back to my fundraiser. Is anybody still watching this?